Hello and welcome to today's physics video, Electricity from Magnetism, U12.EM2. And what we are going to do here today is apply Lenz's law and Faraday's law of induction to solve the problems involving induced EMF and current. So first off we have Lenz's law. It allows you to determine the direction of current, but it does not calculate the magnitude, so we can't really do any problems with that. But it does play a part in a later equation, which is Faraday's law of magnetic induction. This law allows you to find the magnitude of the EMF. Basically it is n, the number of turns, times the induced EMF for a single loop. And the unit of measurement for this equation is volts. The negative sign in the equation is accounted for by Lenz's law, which the direction of the current has to be opposite of the magnetic field, so that's what's going on there. So let's try doing a problem here really quick. A coil has 27 turns of wire with an area of 2.1 meters squared. There is a uniform magnetic field at a right angle to the plane of the coil. The field increases from 0 teslas to 0.4 teslas in 0.55 seconds. What is the magnitude of the EMF? So we'll start by putting our equation down here. And also, I forgot to mention, this equation here has negative turns times the magnetic flux, the change in the magnetic flux over the change in time. The change in magnetic flux can also be written as AB cosine of theta. So that's how we are going to notate this here really quick. And A is area, and B is going to be the magnetic field strength. So now we're just going to plug in what values that we have. So our amount of turns, 27, and then I'm just going to go like this, 2.1 times, and then the change in Tesla is 0.4, so 0.4, and then it's going to be cosine of the angle at a right angle to the plane of the coil, so that's just 1. So we're just going to leave it like that. And over here, and then the time is going to be 0.55 seconds. So here all I need to do is get my trusty calculator out and calculate this. So we have negative 27 times 2.1 times 0.4. And I get this value, negative 22.68. And now all I have to do is divide that by the change in time, which is 0.55 seconds. And I get this number, negative 41.2, and we're going to round that to 4. So the EMF equals negative 41.24 volts. So that's how we do it. We use Faraday's law of magnetic induction, which has Lenz's law in it, to determine the direction. We find the magnitude of the EMF using this, which is the negative negative times the amount of turns times the change in magnetic flux over the change in time. We use that and we find the magnitude of the EMF. So thank you for watching, and I hope you enjoy the video.